Hello. Hi everyone. So today I will stream about Elixir and I will try to solve one challenge from Exercism. So my name is Rakotomalala and I'm one of the mentors on the Elixir track. So we have seen, or some of you have seen, that on Exercism we have currently a challenge, so which is a 12 in 23. So where we can try different challenges, and this month it is the functional February. So for people who want to actually try functional programming, then it is your chance. And one of the functional programs that you can try is Elixir. So what is Elixir? So here I'm on the official page. So Elixir is a dynamic functional language for building scalable and metadata applications. So this is how it looks like. So here, yeah, it looks maybe a little bit for some of you, but I will explain a bit later. So let's get into it. So if you go to also the page for Elixir on exercism.org, you will see a brief description of how Elixir is, with also an example with Hello World, how a typical module look like. So let's go. So here is my GitHub if you want to see a little bit. So if you want to see a little bit more about how I've solved other exercises for the Elixir tracks, it's available here on, so this is my GitHub handle, and this is under the repository Exercism minus Elixir. So today, challenge is the Resistor Colour Trio. I've chosen this one. Yeah, it's this one. So then we go slowly, and I will explain a little bit how we can use Elixir, especially if you come from another language. So let's go. Okay, so yeah, first, maybe some of you actually do not use Exercism. So once you choose an exercise, you can come up on the exercise page where you can actually have the instructions. You can also download the exercise on your machine with some via the command line. And you can also try to solve the exercise directly on the browser. So here I will solve the exercise directly on my computer on VS Code. So here everything is ready. So now we start to read a little bit. So for this exercise, Resistor Colour Trio. So let's go. So if you want to build something using a Raspberry Pi, you will probably use resistors. For this exercise, you need to know only 3 things about them. Each resistor has a resistance value. Okay. Resistors are small, so small in fact that if you printed the resistance value on them, it would be hard to read. To get around this problem, manufacturers print color-coded bands onto the resistor to denote their resistance values. Each band acts as a digit of a number. For example, if they printed a brown band value 1, followed by a green band value 5, it would translate to the number 15. In this exercise, you are going to create an helpful program so that you don't have to remember the values of the bands. The program will take 3 colors as input and output the correct value in ohms. I hope I pronounce it well. The color bands are coded as follow. Black 1, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, and white 9. So in Resistor Colour Trio, this is a previous coding challenge on the Elixir track. You decoded the first 2 colors. For instance, orange minus orange got the main value of 33. The third color stands for how many zeros needs to be added to the main value. The main value plus the zeros give us the value in ohms. For this exercise, it doesn't matter what ohms really are. For example, orange, orange, black would be 33 and no zeros, which becomes 33 ohms. Orange, orange, red would be 33 and 2 zeros, which becomes 3,300 ohms. Orange, orange, orange would be 33 and 3 zeros, which become 33,000 ohms. So in maths, if math is your thing, you might want to think of the zeros as an exponent of 10. If math is not your thing, go with the zeros. It really is the same thing, just in plain English instead of math lingo. This exercise is about translating the colors into a label, ohms. So an input of orange, orange, black should return 33 ohms. When you get to larger resistors, a metric prefix is used to indicate a larger magnitude of ohms, such as kilo ohms. That is similar to saying 2 kilometers instead of 2,000 meters, or 2 kilograms for 2,000 grams. For example, an output of orange, orange, orange should return 33 kilo ohms. So here we have the source of the exercise that you can check. So here it is the repository where all the problems are defined for all the other tracks, for example, Ruby or JavaScript. Okay, so the first thing I see here is the color bands, which could be translated in another kind of data. It's more like a dictionary or a map, as I see it. So let's get started. So first, this is the basic code that we have when we start the exercise for this one, so for this coding challenge. So in Elixir, we have a module. Here's the name of the module that was already given. Here we have the documentation for this function, for the label function. And then we have something special here. It's a kind of annotation. It is to say what type is what type is actually for colors and what type is returned. So if we try to translate it here, it means that the only argument, colors, is a type of a list, but not a list of string or integer, a list of atom. So I will speak about it a bit later. And then here it says that the return value should be such a thing. So here it looks like a bit weird, but it's actually very simple. So it means that we have, so this means a tuple. So it is a special data structure where it will look like this, maybe if I write somewhere else. So here, this is a tuple with only one integer, one element, and here we can have a tuple of two elements. So that means it is strictly two elements. It cannot be more than two. It cannot be less than two. It's always two elements. So here I can have 6 and I don't know, a string. So here it can be 2, but it's always defined. It's not like a list where you can add freely an element. A tuple is strict. You can still use some functions to actually append to the tuple, but it's a kind of rare, but that's possible. So it is like a group of values that are all together. So that means here, so we have two elements. The first one is a number, and the second one is actually one of the things. It can be ohms, kilo ohms, mega ohms, or giga ohms. So this or means like it can be one of them. It's kind of a union, I think. So what is an atom? An atom looks like this. That kind of thing that you see. It always starts with a colon and then you give a name. So in other programming language, it is very similar to a constant. But the difference with other programming language, you need sometimes to write, I don't know, maybe in JavaScript, a const, then the variable name, then equal, and then the value. In Elixir, you don't need. As soon as you define such atom, then Elixir will directly know that we have an atom called ohms, and it can be used everywhere. So that means, in short, colors is a list of atoms, and the result should be an atoms that the first element is a number, second element is one of those atoms. That means we'll have at the end such a thing. Let's say 33 ohms, for example. It will look like this. This is what will be written. Okay. So in Exercism, you have instruction. You have also the base code where you can start, but you have also tests. So if you try from the editor, you will see another tab for the tests. And if you download, the tests are also located in the test directory. So here. So I will execute all tests at once, just to be sure that everything is failing. So mix test, and to be sure that I execute everything at once, because we have pending here, which means that if you want to just code to try to solve one test after another, you can comment them, or you can just do mix minus include pending. That means we are actually testing and including also all tests that have the tag pending. So here there is one tag pending, then all of them have pending except the first one, just to make it sure that just to show to the developer or you that one test that you can actually run the test. So let's go. Normally everything is failing. Good. Red, and it's failing. So let's go. So maybe let's try to make this one run. So I click here, okay. So this thing maybe you will not see on VS Code, so just to a short word about it. You can download the extension called Elixir. So this one here, and just don't forget to put the right directory, and you will be able to make it run correctly, and even to have this useful link to run whatever test you need to. So here maybe a quick thing. So usually you just type Elixir, you search for the folder name, and usually because the Exercism will create a directory just for Elixir, you need also to add it, then just point to the right challenge. You will need to press enter, then just be sure to restart VS Code, or just with this, just try to restart the longest server. Then normally you will see this link later. Okay, so I want to make it work. This one. Test orange and black. Okay, so we should have as result this thing. Let's go. So first what I see, as I said in the beginning, it's just a kind of a map or a dictionary. So we'll start with this one. So I will do, how we call it? Okay, the color bands and color bands. So here, and I know it will be just this one. So now you see you have two new things. We have this one, which is called a module attribute. So it's an attribute of the Resistor Colour Trio. It's a bit like the attribute in a class. It is kind of similar, and this one is a map, like in a JavaScript object. So here, for example, I will just do such a thing, black 0. So here you see that it has the same color. So yes, there are atoms here. So this property is also an atom. You could also write so, but then we need to have, such a syntax. And this one is not an atom. This one is a string. It's another type in Elixir. So for simplicity, because I know that my property will never ever change, it's better to use an atom. If I know that my property is changing, atom then is not the right type. It's better to have a string. So what I will do here, because I'm a bit lazy, I copy, paste it here. Format doesn't work. Yeah, okay. So we select all the last line here. Hope it format. Okay, we have everything from the instruction into the code. Great. And now it's better to make them in a small case. Small case, no, lowercase. Case lower. Okay, this is another VS Code extension. So yeah, then I don't need to type for each of them. So now I have the corresponding map that was in the instruction. So now we have the same data. Good. Okay, so let's try to decode them. Okay, so in Resistor Colour Trio, we decoded the first. Okay, code 33. Okay, orange, black is 33 and no 0. So orange here is a number of 3. So if I have orange, so 3, 3, black is 0, then I should have 3, 3, 0. But then they said we should have no 0. So it will only become 33 ohms and not 330 ohms. Okay. Okay. Then I need first something to decode, I guess. Yep. So I will create a function, a private function. I'll create a private function that where I will actually decode. I will decode from the color. So the objective is that every time I take, let me just make it so every time, for example, I have orange, it will give me 3. Okay, so I can do this way. I take my attribute here and I will just access it. So here with the square brackets, I give color. Okay, then let's try it. Let's try first if that works. So this is just for fun. We just put, for example, orange. Yeah. Atom orange here. And I will just go in the terminal here. I don't know if you can see because of this. Yeah, we put it above. IX. Okay, so here I will just enter the IX, which is the Elixir console, and I will run the project. So it will compile my code. It will enter it. Okay. There are some warnings. So here I will just say, this is the name of my module, resistor label. Because here I really don't care what is it. I will just give whatever. So I don't know, an atom. Okay. Just like test. So I just want to see if I have a 3. Okay, I have a 3. So for orange, it's working here. Okay. So now I need to decode all of them. So if I check the test, if someone give me orange, black, then I have to return this one. Okay, this is exactly what we have here. Okay, so I need first to convert the colors. So here, I will copy that here. Currently, someone will give me such a thing, an array of atoms. Here it is orange, black. And I need to convert them into a number, into 3, 3, and 0. Okay, so for each of them, So here, I could just like make a loop going on each of them and just try to decode them. Then it would give me 3, 3, and 0. That would work, I think. But I think there is a better way. I could actually, because the problem is that what I will have, so here I will have, the target would be to have 3, 3, then 0 here. That would be okay. We try, but I think there is also another way instead of this one. This is a plan A. Just right here. First ID. Now my second ID. Well, actually, we could have also this 3, 3, 0. So here I will have a string, and each of them will be just, each number will be just happen to each other. So instead of having a list, I will have a string. But for sure, I cannot have an integer. So something like this one here, it would work. I will have a 0, but if I don't know there is a, if we have such a thing here, like 0, so black, orange, orange, we might lose a 0 here, I think. So that will not work. And maybe that will not work correctly. But here, I'm not sure. Okay. So I will try, we just try one of them. So I will just, because here I will need to loop through all of them and to decode all the time. But here is the thing. How many items do I have here? I have only 3. Because the purpose of the challenge is just it's not duo, it's trio. I don't know if I pronounce it well. So it is always 3. I will always, all the time, have 3. So if I check here, is it confirmed that I have 3? Okay. We're going to create a user program. That's right. 3 colors and output. That means all the time, normally it's guaranteed that I will have 3. Okay. Okay. So let's go. So I cannot. So then my next idea is actually to pattern match. So pattern matching is one thing that you can do in Elixir. Just it's a bit like destructuring, but it's actually checking for each value. Are you this type, or are you formatted this way? So I will come into it in a few seconds. So I will move my IDs here, and I will start. So I know that speak about the resistance. So if I go down here, just to, I have a resistance, and the whole, which is the whole, like the whole I mean the whole resistance, or the combination of the 3 colors here, and I will convert the color into the resistance. So we call a function here to resistance. Let's create a function, a private function here. That will be this name, to resistance, with only one argument, which is the color. Colors. Okay. So here I'm sure 100% that there's always three elements, three atoms. So, and those atoms are those colors here: black, brown, red, orange, yellow. So I will go color 1, color 2, color 3. Here, normally, in other programming language, we don't do that, but in Elixir and in some other programming language, you can actually say, instead of having just colors, like, and just say, get the first element, then get the second element, and get the third element, you could actually say, like a bit like in destructuring. So just in this array, I know it must be an array, and in the first element, I will assign the value to color 1. In the second element, I will assign the value to color 2, and the third element will be assigned to the color 3 variable. So the equivalent here in other programming language, if there is no pattern matching, we have to do so. Colors 0, color 1. We have to do so with 3 lines. Maybe in JavaScript, you could destructure, you could use destructuring. So I guess it's kind of similar, I think, to the destructuring of JavaScript. So now I have my 3 colors. I have to do something with them. I will try the ID number 2 instead of having them just in a array, because it's actually easier to add at the beginning or at the end thanks to the string module. So we'll see later. So string here, and I will, no, not yet. So I will just use as a string, and I will do the ID number 1, which was just to have my result would be something like this for orange, orange, black. So okay. So here I will have something here which is similar to this one. So here, this is an atom. I will have also an atom here, which is the second color, and I will have the third color here. Okay. So here now I need to decode each of them. So here right now, if I'm not even at 330, I am currently at something that looks like this. So orange, orange, black. But I want to go to the 330. So I will use decode color on each of them. Decode color. So here, okay, we just like paste. Okay. Once I've done this thing, here we should have like 330. So let's see. It will complain. It will complain. It won't like it. Oh, not that way. Something is missing. Yeah, I do not choose resistances. Yes, that's correct. Okay. go here, undefined mix. There is no such import. Okay. Did I try to restart? Maybe there is something wrong here. Import it. Okay, okay. We have the warnings. Okay, we close this one. This is weird. Ah, he was trying to execute this in other console. Okay. So here, the test says that, well, this is what's expected, but I just wanted to see if I have at least a 330, and yes, it's working. So we have our resistance represented with a number that are inside the string. So we have like the 330 very close to what we have, but they say no 0. So I have to remove them somehow. But this, what I have is the resistance. For sure. Okay. Now I need to remove the last 0. So after I have decoded them. Okay. So this one is has give me trouble. So I need to get rid of this one. Okay. How can I do this? For sure, I will have a function here. Okay. So let me read again the instruction. So here, describe a little bit what we have. Each pen acts as a number. If it's printed, okay, these are the colors. Okay. Here, 1, 5. Okay. So it's more here. The third color stands for how many 0 needs to be added. Okay, this one. So the two colors are just the numbers to just represent how many ohms. But then we have the third one. The third number means that I need to. It is just how many 0 will add to the main value. Okay. To the right, I think. So it is to add 0 to the right side. So okay. So red here is 2. So here, if we have orange, which is 3, 3, red means I will have 2, 0. So I become 2, 0 to the right. Okay. Okay. So I will call it just my function pad zeros. It's already here, pad zeros. Pad zeros depending on the color. So if I have red, I will have 2, 0. If I have black, I will have just no padding. So it will still stay just 33. Let's do it. So here, this is now here that we have to use a string. So yeah, I open the string documentation, functions, and we have, I could search here also, pad trailing. Okay, pad trailing, return a new string padded with a trailing filler, which is made of elements from the padding. So here we have an example. If I do this one, it will just fill out with the missing, so if here it should have a string of 5 characters, but as it is only 3 characters, it will add actually 2 spaces. Okay, but padding here, no, we don't want to add spaces, and we don't want to add this. We want to add zeros when it is necessary. Only when it is necessary. So if I have black, I will not add zeros. But if I have red, I will add 2 zeros. Okay, I will try with this one. I will even open. Here we go to the console IX to try directly if that works. Okay, it is working. So now we try with my ID. I have 3, and let's have red here, which is the value of 2. Okay, here it's not adding. Yeah, because it should be 5. Then it will have 5 spaces. This is not what we want. This is not path trailing. This is not this. I need something else. I need something to add at the end. I could still do no, that will not work. I was thinking about looping and then add, but this will not work neither. I see something called duplicate here. Duplicate, it will add, this adds this will duplicate the string multiple times. So if I put twice, then I will have ABC, ABC. So ABC twice. So I try in the console, that's working. Okay. Let's try with, I want to duplicate the zeros. Twice. This is like red. Okay, I have 2 zeros, and here I have 5 zeros, then I will add so. Okay. Then I could concatenate, so I have like 3, 3, and I will try to concatenate with the rest. Okay. This is working here. Let's go. So I will try to pad the zeros. So here I duplicate all the zeros. A string, not integer, string, with the color bands, here. Okay. So this will give me the string. All good. Problem. We need a number here. I don't want 3, I don't know what is this one. It's 3 million. 3,000,000 as a number, not as a string. So I need to convert this thing. So we do so integer. So I just copied just before. So I do. No, it is. I guess it's string to integer, because we go from string to integer. So string to integer, and I paste the whole stuff. Okay. So this will give me the numbers here. Okay. I mean, this will convert the zeros into numbers that I can add later. So then for this one, the padding should come here. Yes. Oh wait, the conversion is not here. The conversion, I need to convert the resistance. So this is my string. So first I need to duplicate the zeros. this is where the padding will be. So if I have 3, the first 3, the second 3, then I have all the zeros here. So I can keep them as a string. And the whole conversion of the string to integer is actually in the resistance. So I go here. Okay. So now I should have 33 as a number. Okay, I have 33. So now I just need to add the unit. So, okay, so the unit, I need the unit. Oh, the unit, it is this one, this one, this one, or this one. Okay. So I need something to unit, or no, I don't know how to call this one, maybe to unit, and I give just the resistance. So then I will know if I have ohms or kilo or whatever later. So, and from this one, then I will be able to put the whole result. So this is my unit. And later here we will have the result just after. But first we need a function to unit. Okay, so I will just, for now, just return ohms, because I don't know for the other yet how to handle that. What I want is this just to pass the first test. Yeah, of course. It's complaining because I forgot one argument. Okay. So 1 half 2. The first is a number, so the resistance I put here. This is my tuple here. I respect the structure from this one. The resistance is here, and the second element in the tuple is a unit. Will it work? Yes, finally we have our first working test. Okay, so let's go to the second one. It's working. Third one. Not working. Ouch. Ouch, ouch, ouch. Yeah, of course. We just focused on the ohms because we just focused on the number. But then we have now to do the conversion of units. Here it should not be 2000 ohms. It should be just 2 kilo ohms. Let's do this. So here 2 units. I said for now we just return ohms. Yeah, I didn't. I just wanted to make the test pass. So now how we'll do that? So I know for ohms, it is just a basic unit. For kilo, it is 1000. Okay, so I will do, such a thing. When my resistance is more than 1000 here, I will just return kilo ohms. Otherwise, I will just do ohms. This. So this is maybe new for you, but this is like conditions. And those things here, what you see, are called guards. So it's actually these things, what I'm doing here, is the equivalent of if I do such a thing. To unit, so I command those two to unit with the resistance. And then it will be like a kind of if-else, but you have several ways of doing conditioning Elixir. You have what I've shown just before. You have also the case, where you could just do this. And then you just say when, so with a guard, when the resistance is bigger than, and here I will do something, I will do kilo ohms. Otherwise, I will just do ohms. I could do that also. Or we could do something very similar also to other language, but with the if-else. This is like with a const do, where actually I could just remove this. Here I could just put true. So here it means just the same. It's just checking, is it 1000? Is it all above 1000? Yes, then I will just return kilo ohms. So obviously, since there is no return keywords, so all the time we are returning each function the last instruction. That means in label, I'm returning this tuple, and in toResistance, I'm returning the result of string to integer and the rest. And in these things, if there is nothing just after, it will just return the result from this one. I could even do this. This is my result here, and do so. Because everything is a function in Elixir. This is also possible. But to make it short, you can also do when you want to return directly the value, you don't need to make an assignment, and you just do this. But I have a preference to this one because I want to show you pattern matching. And guards, I mean. So here, if it is kilo, if I have more than 1000, I do kilo, and otherwise I do ohms. Which one was not working? We try. Okay. Now kilo ohms is there, but not this one. This one is still not converted. I need to convert the value. Okay. Another function will convert the value. I don't know, resistance. And the unit. Okay. So here we take the resistance and I need to divide by the unit. So the unit is like 1000 or 1004 kilo. So here we just put the unit. And I will take that and I need to round it. So I put that between brackets. I need to round this thing. That will give me the result. So for example, here I will go to the console. I have a resistance of 2000 divided by the kilo. I will have this, but I don't want the comma. So I need to round it. I will have such a thing. So once I convert the value, so here I have the unit, I need now to convert the value. So I can maybe do this here. I have the converted value, or even better for more like converted value. Boom. Here, where it's complaining. Convert value, yeah, to arguments. And this one will never return since it's different from the second argument. Okay, why it's complaining has no local return. Convert value has no local return. Okay, that's weird. Did I copy correctly? Okay. Let's try to run the tests and see. Oof, it's complaining. Okay, no, that was this one. But even though bad arithmetic operation. Okay. That's weird. Yeah, the unit. Ah, of course. Yeah, because the unit are just, I was lost in my thought. They are just atoms here. Here is it's not a number. I need something to be able to convert those things into number. So I need another map. And this time, here I will start with homes. My item homes. This is just 1. Yeah, just I mean it is just a basic number. So just 1, and then I have kilo ohms. I will just copy paste not to make mistake. Kilo ohms here, which is 1000. Then I have mega ohms here, which is poof, that must be it. Yeah. Oh, and then start to be quite much. Okay, then we have giga, and here I might make some mistake. Here, I don't know. I will just put 0, but I need to convert that not to make mistakes. So I forgot the comma here. So in the exercise essay, we can actually give a hint that we can use the exponents. So let's do that. So I know for this one, it's just exponent 1. So to do exponent in Elixir, let's see if it's correct. No, okay, maybe 0. Yes, okay. But here it's 1. So but let's make clear. So this is like the ohms. It's like it is just to just be this. Then for kilo, I want 30, so I will just do 10 exponent 3. Right? Is it correct? Correct, 1000. So now I want 60, so I do 10 exponents 6. Is correct? Yes, so I think giga here, exponent 9. Whoops. Okay, it's here. So now I need to convert the unit into the real number. Those things. So I need to go to, I need to convert the value here. I have the unit here, right? So I can either give it here. I have a unit. Yeah, I will do that. I will do that here. Unit, I don't know, to number. It's not a nice name, but then I will just take my unit. Units plural. Okay. Now is it working? Working. 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 Not working. Yeah, because I didn't continue for the other thing. So we have to do the same a little bit here. So it means that for kilo, that will be this thing. Then I have to do for mega. For mega, I have to do this. And for giga, I have to do so. Ah, yeah, I cannot invoke a function. I cannot do that in the guard. There are some functions that you cannot do. You can do basic stuff, but not not this. Okay, then I have a plan B, because we are almost, we don't, I mean, we are almost there, but this is not allowed. So what I will do, it is just, I will reuse the numbers from here, because in units right now we'll have here 1000, 1 million, and so on. So I will just reuse the unit attribute. I will access it, the dot notation. And here I want gigaohms. I will do this. I will do that everywhere. So here it's kilo mega. Here it's kilo. Okay, is this working? So let's go back to the kilo. Yes, mega. Yes, back. Yes, giga. Yes. Next one also. Okay, it's like all of them are passing. So I will go here. I will include all of them. So it's not written. I did mix test minus include panning to see if everything is working. Everything is passing except one. The last one. Ignore extra colors. So here there are 4 colors, but they said we have only 3 inputs here. Only 3 inputs. So if someone is giving us an extra input, we should not accept it. Okay. How can we do that? Where is this? Let's go back to the failing test here. Okay, here it says weird error, function close error, no function close matching in resistor color trio to resistance. It doesn't like, so this thing, there is an error on this thing. No function close matching. So remember that I spoke about pattern matching. And here it says that there is no function that is matching. So currently, with 4 elements in my list, it is not the, how can I say that? That with 4 elements, there is no functions with it. We are just strictly saying we must have 3 elements in the array, in the list. If there are 4, I don't know this function. We don't have 2 resistance with a list of 4. That doesn't exist here. We strictly have 3. So what do we do here? I could do so. So here we still want to execute this code, but we don't want to execute something extra, because I could do 2 resistance and do something else like this. Like if I have 3 elements, I will do like above, and if I have 4 elements, this, I will just do the same, but I will just decode only the first one and ignore the last one here. This means I ignore the last element, and I guess that will work. Okay, and if I try everything, it's working. All tests are passing. Okay, that's a victory, but this is not nice here. I've copied the whole stuff. This is not good. There is a way to say that I want to execute the same thing as above, but without repeating myself. So I will remove this down. And this time here, let's say I add this one. Just I want to show you that there is a difference. So let's say here I add it again because I put like I just ignore this one. That will not work because that says I want strictly 4 elements. Here it's just to say that we are not using it in the function. The fourth argument is not used in the body of the function, but during the pattern matching, it is checking, do I have 4 items, an array with 4 items? And most of them are always 3, like in the test that we have shown before. So to do that, I use this. That means I want the first items in my list. And here, this is the rest of my list, the tail. I ignore the tail. Even if there is 4 elements, 5, 6, 7, 10, 1 million, I ignore it. It will not, in the pattern matching here, it's more flexible. It means I can have 3 elements at least, or I can 4, 5, 6. Is it working? Everything is working. Very good. So we can definitely improve this code. So let's do it. Now we can refactor all the things. So here, directly what I see is that we could just make, let's try to make this only one line. So there is a short syntax for functions in Elixir where I can do this. So do, the keyword is still there, but this time I add the colon. And then I just add the thing at the end here. Is it working? Just to see. Okay, I will do the same for all of them. So instead of having def, do, then end, or def p, do, and end, you can just do def, comma, do, colon, or def p, comma, do, colon. So we'll do that quickly everywhere. Okay, this one also. Okay, next we need, yeah, this one says resistance is unused. Okay, when a variable is not, an argument is not used in the body, I can use this one. I could even do this actually, just to say resistance is not used in the body. But you can also do this way. So let's keep it here. So that means here 2UNIT is accepting resistance as argument, and it is just ignore for the last function, for the last clause, because yeah, we have 4 clauses, but it is just a 2UNIT function of argument 1, of RET1. Okay, let's try to improve this one maybe. To make it a little bit shorter, I could do this one. It's still working. Yes, as it is short, maybe I can just do also one line. Okay. That's okay. Or okay, that's good. Then this one maybe could also be one line. Is it working? Yeah. And this one is, yeah, it's very special. I don't think I can make it in one line, but let's see. Okay, formatted. It will look like this. Okay, that works. Then this one is the most complicated. So let's start from this one. So this one depends on this. This one depends on this. Okay, that means I will use something pipe. So it is something that we have seen in the beginning of the video. So it's like a chain, like in JavaScript, you have like method 1 dot method, sorry, method 2, sorry, dot something. But here, instead of that, we use pipes. So we should right now. So let's do this. I think I can have, so resistance is there. So 2UNIT, okay. So we need resistance because it is used later. So I will use from the end. So I will start from this one. Oops, sorry. I will do this way. And I will just pipe. It means that I will give that to the next function. So the value will be given to this one. So this one is done. After that, I need to give to, so the resistance, I pass it to the convert value. So convert value here, unit. So when I pass a value to another function, it is given to the next function as first argument. So that's why now resistance here is gone because it's passed from here to here. Oh, no, this is a mistake because here it is a unit. So I will just copy here. Here there will be something special because actually, normally, as I said, the first argument is the value that was passed before the pipe operator. So that means I have to use something special. It is then. The capture operator. So here it's a little bit advanced. That means the value that I have before, I want not to pass it as a first argument because unfortunately it's resistance. I need to pass it to the second argument. And I will do this one. That means this n%1 is actually the result of 2 units here. If let's say resistance was passed here, I will not need to do that, and I will just remove resistance in the first place, and we just keep unit. So I repeat, just by doing this, we just give the result of this function, and we pass it to the then, and with the end one, we just say so the 2 unit will be at this location. So as a second argument, I can remove this one. And now we have this is the converted value. Okay. Now I can have this. Let's see if that works. No, of course, because this is a converted, this is a unit. Okay. Converted value. No, this will not work. This will not work. So this is a converted value. Okay, so I need this one, and I need the units. That will not work, unfortunately here. Correct. This will not work because I actually need both of them, so I cannot pipe it. So I just revert. Unfortunately, no pipe here. So just Okay. Let's try. Converted value. I can still pipe it here. So I could do something like this, like resistance. I remove here, and then I just say with then, because here I have no function. So then it's when I have another function, and here I want to pass it to the data structure, the tuple. So I will just add the n% at the beginning, and then I will just say that the convert value will be at this location because the convert value is here. So I just say convert value be here, and the unit stay in the same place. So let's see, it's working. So this is kind of, it's a short syntax. So the equivalent of this one, here we just like copy. It is like doing this way, just like I have converted value here, and I will have this converted value unit. It's the same, but you see it's very long to write, so it's better with a short syntax. So the n%1 is actually the first argument here. Okay, and now it's working. And that's all. So now I have all the tests are passing, and we have our whole solution for Resistor Colour Trio. Okay, yeah, we are just 2 minutes after the limit. So I hope that you have learned from it, and maybe you will give a try to Exercism and also to the Elixir track. So that's all for me. Hope you liked it. And bye.